Hey guys, so everybody's doing okay? What we're going to do today is go through a really big review stoichiometry problem. And this is going to incorporate basic stoichiometry, limiting reagents, excess reagents, calculating the excess, and it's going to also include percent yield at the end. Okay, so this is going to give us a really good idea of where you need to continue to prepare for the stoichiometry test, what you're good at, what you're not so good at, where you need to improve, and I'll kind of scaffold the problem for you so you'll do different chunks of it. You'll see the answer, and then you'll be able to move through the problem that way. All right, so let's get started with this, and let's read number 1. It says, how many grams of zinc sulfate will be produced from a reaction between 10 grams of zinc, 25 milliliters of 6 molar sulfuric acid at a temperature of 30 Celsius and a pressure of 1.15 atm. So it looks very overwhelming, but let's try to break it down a little bit, and you'll see that it's really not that bad. So let's go ahead and write our chemical equation first. So we know zinc sulfate will be produced here, because it says that, and it's going to be from a reaction between 10 grams of zinc, so we're going to add zinc, and sulfuric acid, so that is H2SO4. We're going to produce zinc sulfate, and it doesn't say what else we produce, but we should look at this and say, well, we're missing something. It's a single replacement reaction. We're missing the hydrogen gas. Let's go ahead and balance it, and if you notice, this is actually probably the easiest part of the whole problem. It is already balanced for us. We assume coefficients of 1 are across the whole thing. Okay, let's go ahead and label our information on the problem. It says we have 10.0 grams of zinc, and we have 25.0 milliliters. So automatically, I convert that into liters because I know I have to go to liters anyway. So that is 0.025 liters, and I have 6.0 molar sulfuric acid. Remember that 6.0 molar is equal to 6.0 moles of acid over 1 liter. So we're going to use that conversion. Remember, we can unpack that and use that. It says how many grams of zinc sulfate will be produced. Okay. Now it says we have a pressure of 1.15 atm and 30 degrees Celsius. Let's see if we need that. So I know I have to do what type of problem here? Well, it's going to be a limiting reagent problem because it even says for number 2, determine the limiting and excess reagent. Okay. So what I'm going to have to do here is convert all of this from the sulfuric acid into grams of zinc sulfate. That should be question mark grams. And then I need to convert the 10.0 grams of zinc also into grams of zinc sulfate. Okay? So remember, I'm given 2 reactants here. When I'm given amounts of 2 reactants, I need to make sure I do 2 stoichiometry problems. So let's map it out here. We need to have one problem where we start with grams of zinc, and we're going to end up with grams of ZnSO4. We have another one where we have our information on sulfuric acid. So we have our 25 milliliters, or 0.025 liters of 6 molar acid, and we're also converting that into grams of ZnSO4. All right, let me move that over a little bit so we could actually write our number in there. Okay. If you map this out, if you look at your stoichiometry roadmap, we don't actually end up using STP or non-STP conditions. So this 30 degrees Celsius and 1.15 atm is only going to come into play if we're dealing with the gas that's in this equation. The gas in this equation is hydrogen, and it looks like so far we're not using that at all. So we really don't need to worry about the 30 Celsius, the 1.15 atm. That's just decoy information. So students always end up looking at this and they're like, they see those numbers, they jump right into Pivnert, or using PV equals nRT, and that's something that you don't want to do unless you have to, right? You don't want to do all that algebra unless you have to, and in this case we're not even dealing with the gas hydrogen at all. Everything else is not a gas here. Zinc is a solid, sulfuric acid is an aqueous solution, and zinc sulfate is an aqueous solution as well. Okay, let's go ahead and figure out the stoichiometry then, and we will go from there. So I know I'm going to have a three-step process here. If I look at my stoichiometry roadmap, so let's go ahead and solve it. I'm going to cancel out grams of zinc and go to moles of zinc. Cancel out moles of zinc down here. Go to moles of zinc sulfate. And then cancel that out into grams. All right, let's go ahead and plug some numbers in. Molar mass from the periodic table is 65.38 grams of zinc. Coefficients from our balanced chemical equation, we have 1 and 1. And then grams of zinc sulfate, you need to find the molar mass of that, and that is 161.44. You plug it all into your calculator, and you get a mass of zinc sulfate of 24.7 grams. Okay, let's go ahead and do our other one then with the sulfuric acid. Since we have a limiting reagent problem, I don't know if I'm going to run out of zinc or sulfuric acid first. So let's go ahead and start that. And remember, if you can unpack that 6.0 molar into 6.0 moles per liter, that is what we want to use here as a conversion factor. So we've done a couple of these before. You're going to start with your volume of acid. And you're going to say, again, going back to my point a couple minutes ago, you have a volume here at 25 milliliters. It's not a volume of a gas. So remember, on your stoichiometry roadmap, you have volume in two places. You have volume of a gas, you have volume of a solution. It's not hard at all to figure out which one you're using. Gases are like hydrogen, oxygen, CO2. It might be labeled for you if it's something you're not familiar with. But of course, sulfuric acid is not a gas. Like you should never think it is. So you have a molarity there, so you know it's a solution. So automatically you're going away from the Pivnert stuff, and you're going to solution chemistry using molarity. So let's start with our volume of solution, 0.025 liters of H2SO4. And if you look at your stoichiometry roadmap, it's a three-step process. So you go from molarity to mass of substance B. Okay, cancel out liters of H2SO4 and go to moles. According to our roadmap, cancel out moles of H2SO4 and go to moles of ZnSO4. Cancel that out and go to grams. Okay, go ahead and plug in some numbers. We're going to look at what we unpacked up here. We unpacked our molarity into a ratio of 6.0 moles per liter. So we plug that in. Coefficients in our chemical equation, 1 and 1. Moles of zinc sulfate for our last step, 1 on the bottom, and 161.44 at the top. Calculator time, go ahead and plug it in, and you get 24.2 grams of zinc sulfate. So, question 1 says how many grams of zinc sulfate will be produced? The answer to question 1 is 24.2 grams of zinc sulfate. All right. Question 2 says determine the limiting reagent and excess reagent. So remember, the limiting reagent is not zinc sulfate. The limiting reagent is a reactant that you run out of first. So it looks like sulfuric acid is going to run out first because it only produces 24.2 grams of zinc sulfate. And our 10 grams of zinc, that produces 24.7 grams of zinc sulfate. So this is our limiting reagent, it is the sulfuric acid, and our excess reagent is the zinc. Okay, moving on to number 3. Determine how much excess reagent is remaining. So this is a very common question, and we want to look at it in a couple different ways here. So we know that zinc is our excess reagent. So we know that the 24.2 grams of zinc sulfate is how much product we are going to create here. What I could do is take that 24.2 grams of zinc sulfate, since I know I created that, and do a stoichiometry problem and convert that into grams of zinc. That's going to tell me how many grams of zinc I needed to make the 24.2 grams of zinc sulfate. Okay? Or I could do something else. I know my limiting reagent was a sulfuric acid. I know my 25 milliliters, or my 0.025 liters of 6 molar acid, I know that was all used up, right, with the zinc, because the zinc was in excess. So what I could do is take my data for the sulfuric acid, I could convert that into grams of zinc using stoichiometry. And when I do that, I could again get the amount of zinc that was needed to react with all of this sulfuric acid, which is limiting. Either way, if you go from the 24.2 grams of zinc sulfate into grams of zinc, or if you go from the data on sulfuric acid into the grams of zinc, either way, you're going to get the same number, which is really, really cool. You get the same number for how much zinc was needed. So again, it's either how much zinc is needed to react with all of the acid, or how much zinc is needed to create 24.2 grams of zinc sulfate. So if you're bored or don't believe me, try it. Convert both of those, the 24.2 grams of zinc sulfate, the data from your acid, convert both of those into grams of zinc, you're going to get the same number. What I decided to do was use the data from the acid and figure out how much zinc was needed to react with all of this. So that is what I'm going to do for my stoichiometry problem down here to figure out my excess reagent, how much is left. So let's start out with my initial conditions of my sulfuric acid. 0.025 liters of H2SO4. Cancel out that. Go to moles. Okay, cancel out moles. I want to go to moles of zinc here. Cancel that out and go to grams. All right, let's plug some numbers in. I know my relationship here between moles and liters was 6.0 moles per liter. Balanced chemical equation is 1 and 1 for my coefficients. Put a 1 there in the denominator next to moles of zinc. And I use my molar mass, which I know is 65.38. Okay, I do the math, I plug it in, and I get 9.8 grams of zinc. Okay, students are always, they never really know what number to pick sometimes because they don't think it through. What you want to do here is understand what's actually happening. So the more you understand of this process, the easier it is to obviously understand what these numbers mean. So what you did here was you took how much acid you had in the molarity, you converted that into grams of zinc. What's that telling us? That's telling us I use 9.8 grams of zinc. Okay, I'm using that mass of zinc to react with all of that acid. Okay, it's not my answer. The answer to number 3 is not 9.8 grams. That's not it at all. I need that number, though, to get my final answer. This 9.8 grams is, again, how much I needed to react with the acid. So 9.8 grams of zinc reacts with all of my acid over here. And what am I left with? I started with 10.0 grams of zinc. I used up 9.8 grams of zinc. I'm left with 0.2 grams of zinc in excess. That is my answer. And that's my, sorry, excuse for a star. Okay? That's my answer here. 0.2 grams of zinc in excess. All right? What students sometimes do when they're asked for excess, they never kind of know how to start it. You want to start with something you know. You know the information from your limiting reagent problem. Okay? What was the limiting reagent? You know you don't have 10 grams of zinc left over. You don't want to start with that. I have some students start with a 24.7. That makes no sense. You're not going to make that, right? You're not going to make 24.7 grams because you're only allowed to make 24.2 grams. So when you have an excess reagent problem like this, start with something that you know you used up, which is the acid in this case, or start with something that you know for sure you created, which is the grams of zinc sulfate in this case. Okay, let's go ahead and do number 4. Which is determining the percent yield if 23.7 grams of zinc sulfate is actually collected in this experiment. So, new slide here. I want to make my percent yield formula. Remember, that is your actual yield of, in this case, zinc sulfate over theoretical of zinc sulfate. The actual yield was in grams, right? It was 23.7 grams of zinc sulfate. And, this is mostly done for us here. I need the theoretical amount of zinc sulfate I should produce. The theoretical amount is going to be right here. We already solved for it. Okay, so the theoretical amount is 24.2 grams of ZnSO4. 24.2 times 100. Oops, forgot that here. And you get a final answer to 3 sig figs, if you do it correctly, of 97.9% yield. That is really good, right? We want to be 100% yield. You're not always going to get 100% yield. You really never are, because of the source of error and just experimental design, how the experiment occurs. You're never going to get 100, but you should get close for a good lab. All right, so pretty good results here on this hypothetical situation, 97.9% yield. All right, it's relatively straightforward if you break it up into chunks. Okay, so we have our basic stoichiometry in the beginning. We do have solution stoichiometry here, which intimidates some students, but if you unpack your molarity, it is really easy to understand. Don't let the decoy information throw you off. All right, so we're not dealing with the hydrogen gas here at all. And just make sure you know what you have to use in order to find your excess reagent. So use something from your limiting values, and you should be in really good shape. All right, guys. We can try a couple more practice problems. You guys can try some, and we can talk about it in class how you're doing. And hopefully this helps clarify some things, but this is really every topic in the stoichiometry unit. And if you have any questions, please let me know. Thanks, guys.